Hello guys, so in the previous video we took a look at how to find the profit maximizing price of razors. Now we're going to add to the scenario the effect of complementary products, because as you know we use blades with a razor. So now let's see what we have. This is the question, and then adding to that this portion, which is suppose that the average purchase of a razor average purchaser of a razor buys 50 blades and you earn in profits 0.15 per blade, and now find the optimization. The optimal profits. What did we do? As we explained in class, we have the price and the quantity, and we again found the with the elasticity, with the linear elasticity is equal to 2. So we found out what happens when the price increases by 1%, that the demand decreases by 2%. So now we have the so what do we have here? We have the question. Here's the question. What is the price? What am I supposed to price these razors? What am I supposed to price these razors? So this is quite interesting. So the question is asking about what's the price. The demand, we already found the demand curve, didn't we? We actually highlighted these two, right guys, from the previous section. We highlighted these two without these, just these two, and we went to insert, we went to the plot, and then made sure that this is selected, and then switch rows and columns, and then we added the trend line, and then finally this is what we're looking for. And as you can see, we can easily find out the linear demand curve to be 18 minus 2.4, the price, which is X. Okay. So we have this done. All right, we have this done too. So now, maybe I don't need this. Okay. So now I am ready to actually, and I also wrote here all the things given to me. I have the price of a razor. I would like to find it. I need the demand. I have it now. It's in a terms of a function. So I'm going to type here the demand to be 18 minus 2.4 times the price, which is this here, the price of razor. And also I have the unit cost in the question is 2. And then I have the number of average number of blades per one razor is 50. And the profit is 0.15 cents. And now I need to find the profit. Of course, I've showed you also how to name all these based on formula and create from selection from the left column, and we've done this earlier. Okay, so now we're gonna add here the demand times, we always have the price here of the razor minus the unit cost of the razor, and this is the first part of the profits here, which is exactly the same formula as the one that we've done here. So the first formula, regardless of the different naming of the cells, it was equal to demand of razor times price minus unit cost. But now that we have a complementary product, which is the blades, we are obligated to add that as well, right? So we're going to add now another term for the blades, and that would be the demand here times the price minus the price. Oh, no, wait. You see, it's not always like that, price minus unit cost. We are actually having the profit already. So this is the profit per one blade, and we know that there's an average of 50 blades here, so this is it. So again, this term is the same exact thing like last in the previous sheet or the previous video. And now we have demand times profit that earned per one blade times each razor will causes an average a consumption or will is associated. So each razor is associated with an average number of blades, 50, amount to 50, and each blade is returning 0.15 in profits. Okay, so now this is how we get this formula. This is the profit formula, and now we are going to set up our optimization problem. Let me point out to something quite interesting. This is the decision variable. This we call it decision variable. So if I ask you in the quiz which one is the decision variable, you should be able to know. And indeed, this is the profits that you want to optimize. This is called the objective function. Oh, right now we don't have any constraints. We're going to have it in the next video. So we're going to go to data, we're going to go to solver, and then we're going to go to the objective right here, and we're going to maximize that. And the decision variable is the razor, and then I think I've done it earlier, and this is, I'm not going to add any constraint because I want to show you that if you are willing to give away whatever you learned in school, that the profit should be over, or the profit should be more than the unit cost, or should exceed the unit cost. Well, this might come to you surprise, because as you can see here, if you price the razor as $1, and if you price it $1 instead of $5, then you're also expected to increase your demand to 15.6. You will be earning, if you're able and to increase your demand to 15.6, you will be able to generate 101.4 in profits. All right, wait a minute. This is not very interesting without actually computing things. Okay. So if I have this kind of demand times, I have the price to be this minus the unit cost, and that would be the profits of razors. I will actually get a loss in razors. Okay, so where am I getting my profits from? In fact, you're getting your profits from demand multiplied by 50 times 0.15, right? And this is where you're getting your profits from. And then this is where the wait a minute. This is plus this guminne, because it's yeah, because it's in negative already. And this is where you've got your 101.4 million in profit from. So this is where you got the 101.4 profit from. Okay? So actually you're losing money, and it's obviously you're losing, of course, 15.6, because it's $2 per razor. You're only getting half. So the other half is equivalent to 15.6, and this is how you're getting this much profit. Compared, of course, to compared to what? Compared to what? How much was the demand here? The demand was 6 times price minus unit cost, and over here again the demand times price, this times this. So now, why don't you add up these together? Here plus here. You will find out that you are making a lot more by decreasing the price of the razor, given that you are able to sell 15.6 in demand compared to 6. This is too much, isn't it? It's unrealistic. This means that you probably maybe gonna have to do some very intelligent marketing campaigns in order for you to boost the sales up to 15.6. So the idea is over here mathematically, the idea is as you can see, there's a quantity here times the price minus the unit cost of the current state, because this 0.1 is the current state given by the question. So your current state is that you're making 18 million in profits, in fact, from razors. Come in there. Profits of razors, and then we have the profit of blades. So we have the profits or profit of razors, we have the profit of blades. Oh no, I don't want it to be this big, just big enough to show everything. And this is the profit of razors, this is the profit of blades, and then again, as you can see, this would be also the profit per blade, but we're using the older demand versus the demand we need to stretch up to. So in fact, this would be a big difference here. So that would be how much increase? That would be this minus this over this. So it would be around 60% increase, 61% increase in profit. Yeah. So this is quite a stretch here, indeed. You actually stretch your demand to over double, to 15.6 million. That's over double the demand, so that you can get also over or two-folds of the profits. So that's quite interesting here. Over here in the previous video, we also discussed this in class, but let me just here put profits based on current state, which is $5 with or associated with 6 million demand, which is going to be equal to the demand times the price, the demand times the price minus the unit cost, as you can see here, and then you will get 18 as we got earlier, and then profits or optimized profits without the or optimized profits without using blades in the problem, in the optimization problem. Well, actually, I'm gonna just write here profits, razors profits. It's gonna be how much? Is gonna be the same exact thing, but here the demand will be 6.6, and then we will say here's the new price minus the unit cost. Now, if you are going to also do like how we did before, blades profits, yeah, it's gonna be definitely with the new demand. Here's this demand, and then it's gonna be if I remember correctly, it is 50 times 0.15. yeah? And then that would be this much, and then the profit is going to be this plus this. So that would be, well, how about here also? We didn't talk about this. How about Blades profits? Blades profits is going to be exactly the same here, yeah? But instead of this demand, it's going to be 6 as a demand, right? It's going to be the previous demand here, 6. As we here, remember we got this demand, yeah, with this price. Now we're going to get also the previous demand with this, and now we're going to be able to get this plus this in profits, yeah, 63. That's quite interesting, isn't it? And then we are going to get 67 here. So we have 63 here, 67. So how much increase? And that would be more reasonable. This minus this over this. And this is 7 or 8%. Yeah, 7. So 7.4% increase in profit obtained. Yeah, if we are able to increase our demand to 6.6 instead of or just 6. So that's interesting, yeah. Under price equal 5 and demand 6. We are calculating all this. This is calculated under price equal 4.75 and demand 6.6 optimized. Yeah, so that is quite interesting too. This is the change rate or percentage change here. Yeah, so at the increase rate. So that's quite interesting, isn't it? And over here the increase rate is even higher. So this is quite crazy and unrealistic for demand. So probably a very good discussion would be, why don't we in fact see what's going to happen if we add a constraint that this demand, yeah, is less than or equal to a certain number that we are able, it's more reasonable and aligning with our capabilities, for example, as a company, let's say up to 9, yeah, and you could add that constraint and then you can solve it and you will find totally completely different situation here. You're gonna get only 32, you see, while if you put it back with no constraint and you think that you can reach as many people as you could, because probably this is, I don't know, state-of-the-art razors. It's probably a product that there's no competitor, it's new in the market, and this will be a very interesting discussion for us to question, you see, that, or to observe or to realize, in fact, the difference. You can realize the difference between the new innovative products that has no competitors in the market, and the importance of speed to actually saturate the market with such a product before the competitors also take part and introduce their own products. So if the market is open to you and there is a very good acceptance rate, then you could probably assume as much demand as your budget, your marketing budget can allow. All right, thank you so much, and I'll see you in the next video.